Next problem. I'm going to take a derivative, and I've got a natural log involved, also some nice hyperbolic functions. So you should know that when you want to take the derivative of the natural log of something, the derivative is just the derivative of the inside over the inside. So this one is really just a plug and chug. The derivative of f prime is what? It's the derivative of the inside. So let's do it. The derivative of tangent is sec squared x plus the derivative of tangent is a secant squared x over the inside, which is just tangent x plus tan x. And that's that. We're done. Let's go to the next problem. I want to take the derivative of this interesting function. Maybe we should recall, in case you've forgotten, that the derivative of arctangent of x, maybe pause the video and see if you know what it is. It's just 1 over 1 plus x squared. And so now I'm just going to use the chain rule. F prime of x, what do? I take the derivative of the outside of arctangent, plug in square root of x. So this is 1 over 1 plus square root of x squared. Then I multiply by the derivative of the inside, which is just 1 over 2 root x. And so this, let's move the half. I'm going to move the half out front. So this is 1 over 2 times, this becomes 1 plus x. So 1 over 2 times 1 plus x. And then there's a dangling root x left along. So we'll grab that one. And there we go. That's that. All right, last problem. We're asked to simplify. These are classic. I'll just write it down how I like to think about it. So let's let theta be the inverse sine of 2/3. You can use any letter that you like. I like theta. We're going to switch this and rewrite this in terms of sine. So theta is inverse sine of 2/3 if and only if what? Sine theta is 2/3. And now the point is you can draw a nice lovely triangle. And so let's do that. Here's my theta. If sine of theta is 2/3, then I know sine theta is opposite over hypotenuse. So the opposite of theta is 2. The hypotenuse is 3. Let's think about the Pythagorean theorem. So I need on the hypotenuse squared is going to be 9. I've got 4, so I'm going to need to pick up 5. So root 5 is what goes there. And then so we can say what? Tangent of the inverse sine of 2/3 is equal to tangent of theta, because that's what inverse sine of 2/3 is, and tangent of theta, just look at the triangle and say opposite over adjacent, and so you're going to get 2 over root 5. Am I going to leave the root 5 downstairs? Why, yes I am. And we're done with the review.